In this lesson, we will learn a new property based on cyclic quadrilateral. Now, what is a cyclic quadrilateral? Now, we know a quadrilateral is a four-sided figure. It has got four sides and four vertices. And if it is cyclic, means the four vertices lie on the circle. To give an example, let us take 4 points on the circle A, B, C and D. So we have A, B, C and D. And if we join these 4 points, we get a quadrilateral. This is called a cyclic quadrilateral. So A, B, C, D is cyclic. Cyclic because the four vertices lie on the circle, and quadrilateral because it is got four sides. Now, the property of cyclic quadrilateral is the opposite angles. So we have angle A and angle C are opposite angles. And if you add them up together, angle A plus C will always be 180. And at the other end, if you take angle B plus angle D will be also 180. So B plus D equal to 180. The opposite angles of cyclic quadrilateral are supplementary. Opposite angles of cyclic quadrilateral are supplementary. Means when you add up, you get 180. So we use this property in addition to all the other properties that we have learned. ABC is an equilateral triangle. Find the measure of BEC. So if ABC is equilateral, A, B and C is equilateral. And you know in equilateral triangle, all the angles are 60. So that we have first statement. Here we have ABC. So this angle will be 60. So we write triangle ABC is equilateral, and that is given to us. That means all angles are 60. So we write angle A equal to 60. Reason, angles of an equilateral triangle. Now let's see if we can spot a cyclic quadrilateral. We have A, B, E, C. All of them are on a circle. So A, B, E, C will be cyclic because the four vertices are on a circle. So A, B, E, C is cyclic quadrilateral. And in a cyclic quadrilateral, we know the opposite angles are supplementary. Now, which is the opposite angles? We have angle A, and opposite to angle A will be angle E. So I can say angle A plus angle E equal to 180. That is a property that the opposite angles are supplementary. So we have 60 plus E equal to 180, and E will be 180 minus 60. The E will be 120. So this angle is 120. So BEC equal to 120. In this figure, we have angle BAC given as 30, and BCD BAC is 30 and DBC is 70. This angle is given as 70. Now let us see which is the angle in the same arc. If you trace angle the 70, it is DBC. Here we have this angle, and it starts off from DNC, and the same arc will be here. So this angle is also 70, angles in the same arc. So that will be our first step. So we'll write angle DAC equal to angle DBC equal to 70, angles in the same arc. Now for the next part of the sum, we have proved that this angle is 70, angles in the same arc. Now we will take a cyclic quadrilateral. A, B, C, D is cyclic because all the four vertices are on the circle. So this is cyclic. Let's mark the opposite angles. Angle A and angle C will be the opposite angles. So we have ABCD is cyclic, and A plus C equal to 180 because opposite angles of cyclic are supplementary, and we know A is 70 plus 30, so A is 100 plus C 180. So C will be 180 minus 100, C will be 80. So this is 80. And let's name that angle. That angle is BCD. Here we have BCD. BCD equal to 80. Now for the next part of the sum. The next part of the sum gives us AB equal to BC. So we have here BC is equal to AB. If AB equal to BC, the opposite angles will be equal, which means this angle is 30 will be also equal to this angle 30. So let's write it. AB equal to BC. Therefore, the angles are equal. Angle BAC equal to angle BCA, which is equal to 30. So we know first the entire angle was 80, right? We show that this entire angle is 80. So we can say now 80, that's the entire angle DCB equal to angle DCA plus angle ACB. So 80 equal to, we don't know DCA, plus 30. So angle DCA equal to 80 minus 30, and angle DCA equal to 50. Let me explain this part again. So we had this entire angle as 80, and we know that here this angle was 30, therefore this angle has to be 50 because the entire angle is 80. ABCD is a cyclic quadrilateral. O is the center. BOD is 160. So we have here BOD is 160. If BOD is 160, remember BOD is the angle at the center. Therefore, the angle at the circle, that is DAB, this will be 80. So let's write this. So angle DAB will be half of angle DOB. So which is half of 80 or half of 160. So angle DAB equal to 80. This is the first part. The next part we have cyclic A, B, PD is cyclic. So quadrilateral ABPD is cyclic. Now if it is cyclic, opposite angles is 180, supplementary. So let's join them. We have ABPD is cyclic. Therefore angle A plus angle P will be 180. So A plus P equal to 180. So we know A was 80 plus P is 180. So P will be 100. So this angle will be 100. So BPT equal to 100 degrees. Now here ABC is given an isosceles triangle in which AB equal to AC. Now if AB is equal to AC, two sides are equal, two angles will be equal. So if this is 50, this will be the base angle, angle ABC, and this angle will also be 50. So we have AB equal to AC, and this is given. Therefore angle ABC, let me mark that angle, ABC will be equal to ACB, which is equal to 50. So angles opposite equal sides. Next we will take the triangle ABC. Now if you look up at the triangle ABC, two angles are given. The third angle we need to find. So we have angle 1 plus angle 2 plus angle 3 equal to 180, which means 50, 50, and this angle A equal to 180. So we have 100 plus A equal to 180, and your A will be 100. So we got angle A as 100. Now we'll use the property of angles in the same arc. Look at A and which other angles are in the same arc. Let's trace angle A. This is angle A. We start from B and C. Angle A will be equal to angle D. Angles in the same arc. So angle A equal to angle D, which is now 100, that is angles in the same arc. Or in the same segment. Next we can spot again a cyclic quadrilateral. Look at B, D, C and E. They're all in the circles. So here we will have a cyclic quadrilateral. That is B, D, C, E is cyclic. So opposite angles will be 180. Angle D plus angle E will be 180. D plus E is 180. But we know D is 100. We have found out earlier. So 100 plus E equal to 180. So E is 180 minus 100. E equal to 80. ABCD is cyclic and ADC is given as 130. So we've got to find the angles. So let's mark the cyclic. A, B, C, D is cyclic. So we have A, B, C, D here is cyclic. So the opposite angles will be 180. So angle D and angle B are opposite. So D plus B equal to 180. Now we know D is 130 plus B is 180. So you'll get your B is 180 minus 30 and this is 50. So we got this angle as 50. This is the first step. Now here we have the diameter. We have AB as a diameter. If AB is a diameter, we know the angle in the semicircle is 90. Let me just draw that again. So we have circle, we have a diameter, and then the angle here will always be 90. So we'll mark that angle. So we have this angle here. So this angle will be 90. So let's write that. AC is diameter. Therefore, angle here we have angle ACB is the angle in the semicircle. ACB equal to 90. Reason, angle in semicircle. This is the second property. Now for the third, I'm going to take the same triangle ACB. Look at the triangle ACB. ACB. We trace it out. We have A, C, B. Here two angles are known. One angle, this is 50. We found earlier. We now found this as 90. Angle C as 90. Now it is time to find angle BAC. So in triangle BAC, angle 1 plus angle 2 plus angle 3 equal to 180. So which is 50, 90 plus angle BAC equal to 180. So it is 130. I mean not 130, this would be 140 plus angle BAC equal to 180. So angle BAC 180 minus 140. So angle BAC equal to 40. So we got this angle as 40. That's what they asked here. Angle BAC is 40. So we use three properties here. First we use a cyclic property. Opposite angles is 180. Then we use angles in a semicircle 90. And here we use angle sum property. CD are points in the semicircle described on BA as a diameter. So let's mark BA is a diameter. If BA is a diameter, that means the angle will be 90. Now which angle? The angle in the semicircle will be this angle. This angle will be 90. So let's write that first. We have BA is a diameter. Therefore, angle BDA equal to 90. Reason, angle in a semicircle. The next step, we spot a triangle where two angles are given. Look at triangle ABD. Let's trace it out. ABD. In ABD we have three angles. Angle A we know, this is 90, and then we will find the third angle. So we'll get on to that. So we take triangle ABD, three angles equal to 180. That is 70. This is 90. We'll take this angle as X equal to 180. So we have 160 plus X is 180, and your X comes 20. So now this X, I'll drop this out, and now we know that this is 20. Now in the next step, we're going to take a cyclic quadrilateral. This is what we found out. Let's take up a cyclic quadrilateral. And the cyclic quadrilateral, four vertices in the circle, A, D, C, B. They are on a circle. So this is my cyclic quadrilateral. And whenever we have a cyclic quadrilateral, what comes to our mind is opposite angles 180. So this angle is not given to me. I'm going to put this angle as y. So I have ABCD is cyclic, which means angle A plus, not A, I'll take angle D, angle B plus D equal to 180. Now we know angle B is 30 plus 20, and for angle D is 90 plus y equal to 180. I repeat again, this is my angle B and this is angle D. So you have 50 plus 90 plus y 180. So 140 plus y 180, and your y becomes 180 minus 40, and this is 40. So I have my y as 40. So they said first find angle ABD. Where is ABD? Angle ABD. That is ABD. And we already found ABD as 20. So ABD is 20. Then they want us to find angle BDC. Now where is BDC? This is BDC. And we found BDC also as 40. So angle BDC equal to 40. We have done the sum earlier, but however we will do it now using cyclic quadrilateral properties. So first, this is given as 140. Angle BOD will be 140. So angle BOD equal to 140. That is the angle at the center. Now to find the angle at the circle, this is the angle at the circle, and if we join this, this will be the angle at the circle. It will be half of 140, and this angle will be 70. So angle BAD will be half of angle BOD, which is half of 140, and angle BAD, half of 140 means it will be 70. So if this angle is 70, now let's go to cyclic quadrilateral. You have A, B, C, D is cyclic. Let's trace it. A, B, C, D is cyclic. Now if they're cyclic, that means you have angle A plus angle C equal to 180, opposite angles. A plus C 180. So A is 70 plus C 180. So C you get 110. So here we got C as 110. We're going to use linear pair. Here we have a linear pair. I will mark this angle as X. So in the third part I will write X plus 110 equal to 180. So X will be 70. This is linear pair. So three properties. One is angle at the center is double the angle at the circle. The next property is of cyclic, supplementary. Opposite angles are supplementary, and here we have linear pair. BD equal to DC. So let's mark here. BD equal to DC. If two sides are equal, two angles will be equal. Two sides equal. So this is 25. Here this angle also will be 25. So let's mark that. So we have triangle BDC. BD equal to DC. Therefore, two sides are equal to angles. Which two angles are equal? We know DBC will be equal to DCB. DBC equal to angle DCB equal to 25. Now we'll take up the triangle DBC. Here is the triangle And in this triangle DBC we have 3 angles which will be equal to 180. So we have BDC, 3 angles, angle D plus angle C plus angle B. So one is 25. Here also we have angle 25, D equal to 180. So 50 plus D 180. So D will be 180 minus 50, and this is 130. Next we are going to take a cyclic quadrilateral. You see A, B, C, D is cyclic. So let's join that up. A, B, D, C. So this is cyclic. And in cyclic the opposite angles are 180. So we have in quadrilateral A, B, D, C, opposite angles, that is A plus D equal to 180. Property of cyclic, opposite angles supplementary. So A plus D we already found was 130. So 130 equal to 180. So your A will be 50. So your BAC will be 50. They've asked us to find BAC, which is 50. Here again the similar sum in PQR, we have 2 sides equal, PQ and PR. So we have PQ equal to PR. If PQ equal to PR, the base angles will be equal. So this is 35, and here this angle also will be 35. So we write that first. So in triangle PQR, PQ equal to PR. If PQ equal to PR, the base angles, which are the base angles? PQR will be equal to PRQ. So PQR equal to angle PRQ equal to 35. Now in this triangle again there are 3 angles. There is angle 1 plus 2 plus 3 equal to 180. So that means angle P plus 35 and 35 equal to 180. So P plus 70 equal to 180. So P equal to 180 minus 70, and the P will be 110. So this is 110. Next we will do angles in the same arc. So you have angle PQPR equal to angle PSR, because the angles in the same arc, and the arc we take is QR. See, from Q and R we go up to P, and from Q and R also we go up to S. These becomes angles in the same arc. Angle P equal to angle S equal to 110. So here I'm going to mark 110. Now we'll do cyclic quadrilateral. QSRP is cyclic. So here we have cyclic. And in a cyclic quadrilateral, you know the opposite angles are 180. S and T will be 180. So we'll have now QSRT is cyclic, which means S plus T is 180. S is 110 plus T is 180. So T is 180 minus 110. So T will be 70. So angle T will be 70. That's what they have asked us, QTR. So angle QTR equal to 70. Here again we have this angle is 160, BOD is 160. If BOD is 160 and BOD is the angle at the center, so the angle at the circle would be BCD, that is X, and it would be half of 160. So we'll write that angle BOD equal to 160 and x is half of angle BOD. So x is half of 160, so x will be 80. So we have now 80 here. And we can spot a cyclic quadrilateral. A, B, C and D is cyclic. So we have A, B, C, D here, that is cyclic. So A, B, C, D, cyclic. So opposite angles 180. Angle A and angle C equal to 180. A plus C 180. And you need to write the reason. Opposite angles of cyclic are supplementary. So our A was Y and our C is 80 equal to 180. So Y will be 180 minus 80 and Y will be 100. So in the sum we have X equal to 80 and Y equal to 100. Now again in this figure we have a cyclic quadrilateral, that is A, B, C, D is cyclic. So let's trace it. A, B, C, D is cyclic. Now in cyclic the opposite are supplementary. So C and A are opposite. So I'll write A plus C 180. Reason, opposite angles of cyclic are supplementary. So we have A plus 100 equals to 180. So A will be 180 minus 100 and that is 80. So this is going to be now 80. Now let us spot a triangle with three angles are given. 1 A, B, D. Look at A, B, D. In triangle ABD, we know angle 70, we know this is 80, we can find out angle ADC. So it's the next property, angle ABD, three angles, 180. So we have 80 is one angle, 70, and we do not know this angle, we put it as X or we put it as D. So this is 150 plus D 180. D is 180 minus 150. D will be 30. So this is 30. So that's angle ADB. So angle ADB equal to 30. ABCD is cyclic and AD is parallel to BC. Let's mark that first. We have it. AD is parallel to BC. So the co-interior angles will be supplementary. Now who are the co-interior angles? I can say angle A and angle B will be the co-interior angles. So let me write that. AD parallel to BC. Therefore A plus B equal to 180. And why is A plus B 180? Co-interior angles. Co-interior angles are always supplementary when the lines are parallel. Now we see a cyclic quadrilateral, that is A, B, C, D is cyclic. Here A, B, C, D. So we have A, B, C, D is cyclic, which means now I can say angle A and C. Angle A and C will be 180. A plus C equal to 180. Opposite angles of cyclic are supplementary. Now if I equate both these equations, I take equation A plus B 180 and I take A plus C is 180. Put them together, I will get now A plus B equal to A plus C. A cancels I get B equal to C, and I have proved. So rather simple sum. It's given AB, CD are diameters. So if AB and CD are diameters, we can say O must be the center because the diameters meet at the center. Now if we take up triangle BDO, in triangle BDO we have OB equal to OD, and these are the radius. So this is equal. So let me write that. So we have OB equal to OD because it is radius. If the radius are equal, the base angles must be equal. So this is 50, here also will be 50. So angle ODB equal to angle OBD equal to 50. So this angle now is also 50. Now here again in the same triangle I have three angles, 1 plus 2 plus 3, and that is 180, which is 50, 50, and here I have angle O. I put it as X equal to 180. So 100 plus X is 180, and X is 180 minus 100. So your X comes as 80. So this X is now 80. But I know they are vertically opposite angles. This 80, this also will be 80 because it's vertically opposite angles. So angle BOD equal to angle AOC equal to 80. These are vertically opposite angles.